Hey guys, welcome back. This is Physics for Life Science, and today we're going to be talking about Coulomb's Law. So Coulomb's Law is mostly touched on second semester physics, and then what it just means, it's simply a way of describing the force of an electromagnetic field, and it just means force is a constant K, which we're going to define in a little bit, times your first charge times your second charge divided by the radius squared, which many times is denoted as k by its own, and I'll explain why. Big Q, little q over r squared. And now the k, what k is just a constant, as I said earlier, and we're going to approximate it in most physics classes as 9.0 times 10 to the negative 9 newtons times meter squared over Coulomb square. And now K1 and KQ are your charges, which their sign is just going, or their amount is going to be measured on coulombs. Thus, where the formula comes from, which is denoted as a C. And then radius, as our metric system defines it, is always going to be meters, which is defined by an M. All right, so now a really quick calculation, right? So if we have, so based on a previous video, we know that opposites attract and likes repel each other, right? So now when we're going to calculate Coulomb's law, we're going to have to leave the signs out. So for example, let's suppose we have two particles. Actually, let me do this. So we have our first particle, right? And then we would have our second particle, which I'm going to use different colors to denote different things. So I'm going to try to make them the same size. So then this would be your negative. Oops. I need to change back to this. This is going to be our negative charge. This is going to be our positive charge, right? So now a charge amount that you will never encounter in physics is 1 coulomb. And I'll explain in the next video why you will never encounter such thing, because 1 seems kind of normal to us, but when it comes to electromagnetic forces, 1 coulomb means a lot, and I'll explain in a moment why. Right, so each one has a coulomb, right? But this would be a positive charge, right? So let's just change here colors from the signs. This would have a positive charge, this would have a negative charge, and let's just say that they are a meter apart, just for simplicity of math. Okay, so now we are going to go ahead and plug our numbers into the formula, right? So now we're going to come here and we're going to say the force between these two particles is K, which we know it's approximately 9.08 to the 9 newtons per meter squared over Coulomb squared, right, times, well, what is our first charge? It's 1 coulomb, but remember, I said we're going to ignore the plus or the minus right now, because we may get confused, because if we put plus 1 here and minus 1 coulombs, of course, here, this gives us a negative, right? It would end up being a negative force. So then you may say, okay, negatives are going to attract, right? And then positives are going to repel, correct? Because a positive and a positive, I'm going to give you a positive force that would repel, and a negative would give you a positive. So now you may do that. However, for physics, most of the time when it comes to forces, you're going to have to tell them if they're going away from each other or against each other. away from each other or towards each other, because the positive and the negative, as you may remember from earlier in the semester, it tells us a direction, right? So it becomes a little bit complicated as to where we want to specify. So if you want to do that, go ahead. But for the sake of this video, I am not going to address that. And I am simply going to keep working as with absolute values. And then just based on our numbers that we have previously, we'll be able to figure that out if they're coming to each other or going against each other, right? Okay, so now here, now we're going to say divided by 1 meter squared, right? Now remember, this is our calculation right here. So let us not get confused with everything else. Okay, so now if we compute this, remember I'm doing the absolute value. So 1 times 1 is 1 divided by 1. Coulombs, 2 coulombs times coulombs, it's coulomb squared. So these two cancel right here. Meter squared cancels right here. So the only value we're left with is, as you may have expected from force, is that the force between these two particles is 9.0 times 10 to the 9 newtons, right? And that's actually a very, very large force if you think about it. So that's why I'm telling you that you're hardly ever going to encounter 1 coulomb. Okay, so now this is the force, right? That's the magnitude of the force. Now, because we know that they are opposite signs from each other, we can say that they're going towards each other. Correct? So, or since, we did it earlier here in the video, positive force means they're going towards each other. And then negative means it's going away from each other. All right, so I hope this helped you guys. I'm just going to highlight again, I wouldn't suggest you doing this, just because once you start encountering 3 particles, it's going to become a little bit harder to see where each particle is going. The overall force will follow these rules, but then you may be asked about a specific charge, and then this rule right here will throw you off. So I will just say do the magnitude, and then based on the symbols, you can figure out the direction. So in the next video, I'm gonna explain to you guys a little bit more about the constant K, just because we didn't talk about that so much, where it comes from or what it means. We simply gave it a value and we plug it in. And if that's okay with you, not knowing where that constant came from, that's fine. However, for a lot of physics too, many professors ask you to work with the definition of the variable K, and I'm going to go over that in the next video. So I hope this video was helpful to you guys. So remember, like us, follow us on Facebook, YouTube, go check out our website, leave us some comments.